We want to graph a function that satisfies the given conditions. F prime of x is greater than 0 or positive on these two intervals, and f prime of x is less than 0 or negative on this interval. Let's go ahead and organize this information on a number line. Notice that the derivative changes sign at -4 and +2. So we'll plot those two values on the number line, and since these intervals are open intervals, we'll plot open points at these two values. On the interval from -infinity to -4, the derivative is positive. So on this interval here, the derivative is positive. Remember, if the first derivative is positive, that means the function must be increasing on this interval, which means it's moving upward from left to right on this interval. And then on the interval from -4 to 2, the derivative is negative, which means on this interval here, the function must be decreasing or moving down from left to right. And then from 2 to infinity, the derivative is positive again, meaning the function must be increasing on this interval. So recording this information on the number line gives us a nice idea of what the function should look like. Notice the derivative changes from increasing to decreasing at -4. So we need to have a high point or relative maximum at x equals -4. And the function changes from decreasing to increasing at +2, which means we must have a relative minimum at x equals +2. So now to make this graph, we're going to sketch a high point at x equals -4. We don't know how high to make it, but as long as it's higher than the low point at +2, we'll be just fine. Let's go ahead and make the relative maximum here. And then at x equals 2, we'll have a low point, maybe somewhere in here. So to the left of -4, the function must be increasing. Then it decreases from -4 to 2. And then at x equals 2, it starts to increase again. So our function might look something like this. The function starts to increase, and then at x equals -4, we reach a relative maximum. Then it starts to decrease. And it decreases all the way to x equals 2, where it reaches a relative minimum, and then starts to increase again. So this would be one possible sketch of a function that satisfies the given conditions. So these types of problems are a nice way to reinforce the idea of what the sign of the derivative tells us about a function. Notice that the derivative would also have to be 0 at x equals -4 as well as at x equals +2, because these are our critical numbers where we have relative extrema. We'll take a look at a second example in the next video.